For the first time, you are in control of your data and you decide how to monetize it and who can see what. You don't need to trust any centralized service provider with that sensitive information. I really think that this is like changing gears in a car. It's like opening up a new design space that wasn't possible before. So there's a lot of room for creativity and innovation.
Hello, everyone. Welcome back to the Unleashing DePIN Podcast. My name is Tyler. I'm your host, and I'm very excited for this next guest that we get to have on the pod, get to learn about all of the different things that they're building. We have Miguel from Nillion. Welcome to the podcast. How are you doing?
Thank you, Tyler. Thank you for having me. I'm doing great.
I'm glad to hear it. I know we were just chatting about we're surviving the freeze. It's very cold. You were enjoying some nice weather and wish we could all go back to that. But all of that aside, excited to chat about everything you're building. Maybe the best place to start is getting just an introduction about yourself. You've got quite an eclectic background, a lot of incredible just things that you've done in various industries throughout your career. So maybe we can start there and dive into everything you're building.
Sure. Yeah, so you can think of my background in terms of somewhere between the intersection of telecommunication engineering, so a little bit of engineering, and mathematics. So I did a PhD in maths. I started my career back in 2000 working for large telcos, essentially planning these large networks, which are distributed, which is like an introduction to decentralization, if you wish, doing all sorts of mathematical computations and measuring traffic and trying to predict what traffic would look like. So I was really interested in the mathematical aspect of that. That is what ultimately led me to pursuing a PhD degree, and where I essentially did a bunch of patents, like 27, on how to model the back end of the internet. So it all started with the internet, but that required analyzing a lot of information, a lot of data. So that was like an introduction again for something different, which is AI. So it started with big data and then AI. So I worked later on a number of AI projects, and in 2013, I think it was, I started working with zero-knowledge proofs, so cryptography, something completely different again. And I got really interested in that part of the maths, of the cryptography. And that took me to, it was like an introduction to Web3. Essentially, I started working in Web2 with authentication and identity verification, but it is impossible to ignore the use of ZKP in Web3. So that's how it all started for me. So that's how I discovered Web3. I met Andrew Masanto, co-founder of Hedera and Reserve, back in 2017, and we were toying with the idea of creating a privacy coin with ZKP, but it didn't pan out. It wasn't the right market conditions, so we kept in contact, and I kept on working privacy-enhancing technologies, different ones like multiparty computation and FHE. And back in the summer of 2021, that's when we met again with other co-founders, Alex Page and Andrew Yo. And essentially, we decided to start Nillion. The idea behind that was to use privacy, to bring privacy into Web3, because we thought that was an important missing piece of the current technology stack. So that's how it all began.
Very exciting. I think the privacy space is probably the most interesting thing to me. I've always been really just fascinated by the application of cryptography in different use cases that can move the world forward in a more secure way. I'm curious, when you were beginning that research phase, were you like interfacing with some of the cypherpunks like Zuko and working with either Zcash, or like what was the initial intersection where you were seeing ZKs and crypto colliding?
Yeah, essentially it was all ZKP, right? It was Zcash, it was Monero, it was Bulletproofs, all the underlying technology behind those projects, and ZK Snarks and ZK Stark, and that was the beginning of it. But then I suddenly realized that technology is great for transactions, for example, but it's a little bit limiting when you're looking at different use cases that require computing on data in a privacy-preserving way without actually showing the data. Because in ZKP, the prover has access to the data in plain text. So that's an important limitation that is then addressed and removed by other technologies, including MPC and FHE, which I mentioned before. So it started with ZKP, but it continued down the rabbit hole, if you wish, of privacy-enhancing technologies. There are many of them, like TEAS is another example, differential privacy is another one. So there's a whole range of different ways of working with private information, and that's how it all started. And I haven't regretted entering that rabbit hole. It's really exciting, and it's really at the intersection of two things that I love, which is mathematics, but also with an ingredient, with a component that has to do with ethics and has to do with the ethos of decentralization, which I completely stand behind.
Yeah, I think that's incredible. There's a really great YouTube video out there that I want to say it's a scientist or some mathematician who explains zero knowledge in different categories, whether it's like a first grader, third grader.
Yeah.
For those that maybe they hear this term thrown out all the time, but they don't necessarily know exactly what it is. Can you give a really cursory explanation or overview of what zero knowledge proofs are and how that relates to everything that you're building at Nillion?
Yeah, sure. So it's all about proving to you, for example, that I know something without really telling you the data. That's something. For example, one example that is very illustrative is that this Wally thing, like find Wally, like there's a lot of people, a picture with a lot of people, and there's Wally there. So the people is the data that I have, and I just want to prove to you that I know where Wally is, but I don't want to reveal anything else. So what I do is I take a black piece of sheet and I just scissor out the shape of Wally wherever he is, and I just show you the picture of the data with that black sheet in front of it, so that you just see Wally, and you know therefore that I know where he is, but you don't know the rest of my data. So that's the gist of it. Is about showing things, proving things to people. For example, I'm older than 18, but I'm not going to tell you how old I am, or I live in Europe, but I'm not going to tell you where exactly I live. This type of thing that is really interesting, and then can find applications in blockchain, because in blockchain you want to prove, for example, that you have properly built a transaction, but you don't want to reveal the amount of that transaction, and you want to prove that there's no double spending associated to the transaction, but without revealing all the details of the transaction. So essentially, that's the idea behind ZKP.
I love it. That's a great explanation. I'm definitely going to steal that from you. The where's Wally or where's Waldo or whatever and I haven't heard that analogy or that metaphor before, so I really appreciate that. So you've been working in this space for a long time in terms of like research and application. And so what was the initial business case or intersection with Nillion specifically that you and your co-founders began developing a few years ago?
So we were thinking of this technology in terms of a new type of infrastructure. So it wasn't a particular use case that kind of inspired us, but rather the observation that Web3, in going from Web2 to Web3, we lost privacy in that way, in that step, right? Web2 is large and it's thriving with use cases that do require privacy. It may be broken, that's true. So there's better things that we can do nowadays with privacy, but it requires privacy. At least the ability for me to hide information, not from the service provider, but at least from the rest of the people, from the rest of the world. And it's very hard to think about almost any use case or service in Web2 without that ingredient. But that's a key ingredient that we lost when transitioning from Web2 to Web3. So we gain other things like decentralization and trust minimization and things like that. But we lost that key ingredient. And we thought, and we believe that's a limiting factor. Is one of the reasons why Web3 cannot grow beyond its current limitations. So it all started as an idea to develop a new type of infrastructure that could sit along existing Web3 infrastructure, like blockchain infrastructure, and provide that kind of privacy or throw that privacy into the mix. And then once you realize that, then all the use cases come easily, because then you think, think about DAOs, you have private voting. Think about games, you have the ability to hide the private state of the game so that you have guarantees that no one is tampering with it, but you have privacy around that secret information of the randomness generation. Think about data analytics. You want to store data, compute on it, but you don't want to share that data with third parties. Think about agents as well, which is very trendy now. The form of agents that we're seeing now is, I think, a primitive stage, because they don't have privacy. But think about agents that could help you. For example, provide you with advice on finance, on relationships, on, tax or health. All of those agents will have to learn very sensitive information about yourself to be able to provide you with that service. So if you want to run them on a decentralized infrastructure, which is a good idea, because then you don't have centralized power and no single company controls your data, you would want to use this type of decentralized infrastructure with privacy-preserving guarantees, which we call the blind computer, by the way. And the list goes on. Once you get the idea of this infrastructure, it's very easy to find use cases, and we're seeing a lot of people actually building them on our infrastructure.
Yeah, that's incredible. And I know that you've coined this term, the blind computer. Can you just give a rough explanation of the various components that go into the network that you guys have built so far?
Yeah, sure. So first, I think kudos to our marketing team for coining that term, which I think it's illustrative of what the network does, even though the underlying technology is very complex. So blind computer is a type of decentralized infrastructure that enables the nodes in that infrastructure to actually run computations on your data or kind of sensitive data without seeing it, and hence the name blind. So they're blindfoldedly running computations on the data, and that's why this blind movement comes from. The underlying technologies are very different, but are very complex. But if you want to have a picture of what this infrastructure looks like, architecturally speaking, you may picture it sitting alongside or beside a blockchain infrastructure. So there is a way to go from a smart contract to the blind computer, so that you can send data over there for computation. And there's a way back as well, so that the blind computer, once it finishes the computation, it can send a transaction into an existing blockchain. Then inside of the blind computer, you can think of it in terms of a clustered-based architecture. So a blockchain would be a monolithic architecture where all the nodes reach common consensus, agreement on the state of the ledger. Here, every cluster is independent from one another. So you can think of it in terms of a multi-processor CPU with the different processors running separate computations. So consensus only happens within each one of these clusters. Otherwise, they're pretty independent. And that gives you a lot of sway, a lot of flexibility when it comes to addressing multiple use cases, because in some of them, you want to have really powerful nodes that run GPUs and things like that for AI. In others, you want cheap nodes. And in some, you want a lot of nodes because you really need a lot of decentralizations. In others, maybe you're happy with a handful of them. So it is really flexible in that regard. So you can see that like a new type of infrastructure that can interconnect to existing blockchain technology.
No, that's incredible. And speaking of the actual infrastructure piece, what does it look like for either node participants coming into the network, for actually joining? Is it a set of specific types of hardware that needs to be available? Is it just procuring different computing resources for people that want to join? Can you share the nuances of those a little bit?
Yeah. So one thing I didn't mention is that this network of clusters itself is governed or coordinated through a blockchain, layer one. So we have a layer one. And then the question is, you can either become a node powering that layer one. The requirements there are very lax. It's just, there's no stringent requirement whatsoever. You can run it on regular hardware. Or you can be a node, because it could be both, but you can be a node in one of those clusters. And there it really depends on the type of cluster. If it's a cluster running, for example, AI computations, then it has to be one with GPUs and with TEs, with trusted execution environments. So we would be talking about H100s, things like that. If it's a cluster about storage, there we would be talking about storage requirements, because you would be part of a decentralized storage, which we call the NIL-DB. And there, what really matters is the ability to store a lot of information on your server, on your node. And otherwise, for general purpose computation, the requirements are usually not that stringent, because again, we're not using very hardware demanding cryptography, but rather quite simple one. So you could get along with a simple computer. So it really depends on where you want to participate.
Sure. For the trusted execution environment, or for those nodes that are in the network that provide like the TE, are we looking at things like Intel SGX type infrastructure? Or what do you require for those types of participants?
Yeah, it really depends, but we don't like Intel SGX that much because it's
insecure.
Yeah, a little bit. So it would be the newer versions of it, right? So we were talking about all the things from NVIDIA, and even the newest T environments from Intel are fine, but it's the next generation after SGX, essentially.
Okay, that's incredible. And so you have your own L1. I believe that's on Cosmos. Is that correct?
Yeah, exactly. It's using the Cosmos SDK. Yeah, that's
interesting.
correct.
And what was the rationale of the decision behind building on Cosmos for the builders in the room that are curious to evaluate these different chains?
Yeah, from the technical standpoint, is really modular and it gives you a lot of freedom when it comes to configuring it. So that was one important factor. And then there's the business, more kind of business reason, which circles around the fact that this way we are an L1 because we are a core infrastructure project. It wouldn't make sense for us to be like building on top of another L1 because then it didn't conceptually, it didn't make sense. So we wanted initially even to be an L2, but we had problems around finality. And that's when we decided to use Cosmos to build it from the ground up and become an L1, essentially.
Yeah, I think that makes a ton of sense. I know that there's a few other components to your architecture within the different types of infrastructure, which is you have private oracles, there's the data blocks. Can you unpack a few of those other components that are really relevant to what you're building?
Yeah, so essentially we have three core components. One is called Nillion, which is a general purpose privacy-preserving decentralized compute infrastructure kind of technology. Then you have NilDB, which is the storage one that you mentioned, which is used for storing data in decentralized way, but without revealing it to the nodes. And then we have Nil AI, which is for running all these AI computations, private inference, things like that. But then you need to connect that to existing blockchain technology. That's when you need the interoperability element. Then you need it to be coordinated with our Cosmos blockchain. That's what we call the Nil chain. And you need it to be connected to the outside world. And that's where you come to these private oracles that you mentioned. Essentially, those are now under development, but the idea is that we want to go one step beyond zk-TLS. So with zk-TLS, you have a way of injecting private information from Web 2 in a verifiable way into Web 3. But what you end up with is a zero knowledge proof that says, oh, I'm older than 18, or some statement computed on the data that you access from your private Web 2 service. But you cannot really perform computations. So we're working now with some partners in the development of the new iteration on this technology, which enables actually for the computation on that private information in a verifiable way. So essentially, I'm able to prove, oh, this information comes from this web service in this private web service. Like, for example, it could be something like Equifax for credit scoring. It could be Netflix. It could be any Web 2 service. And I can compute on that information without revealing it to my network. And then the result from that computation can end up in a blockchain, for example. So that is what we call a private to private oracle. The original oracles were public to public because it's public information going to a public blockchain. Then the zk-TLS oracles are private to public. So you access private information in Web 2, but it ends up on a public smart contract, so in Web 3 infrastructure. But these are private to private because it goes from private Web 2 to private Web 3, and you can compute on that. And that's the next iteration on this technology we're really excited about. Yeah, so those are different elements in the architecture in more detail.
Yeah, I appreciate giving the breakdown, and that really sounds like it's going to lend itself incredibly well to this sort of burgeoning or flourishing world of AI agents that people are getting excited about because of the private-to-private capability that you have on the network. Is that fair to say?
Yeah, exactly. This kind of opens, if you think about most of the interesting information is private, and it's sitting in Web 2 behind firewalls and encrypted services and whatnot. Think about what Chainlink brought by unleashing just the public side of it, which is the tiny fraction of it. Now, this could be much bigger. And in particular, with what you're mentioning about agents, this unlocks a lot of opportunities because now I can feed my agent with the data that I have from my financing services in Web 2 or from my health services or whatnot, all the different types of information that you have in Web 2, like social media, online shopping, job platforms, emails, you name it, literally. All of that can go into an agent that runs on top of decentralized infrastructure, so no one is controlling it, and you have guarantees as to the fairness of that service, but no one is seeing that data on a blockchain, which is a core element. And everyone has the guarantee that data came from a verified source in Web 2. So you have the whole, you're finishing the whole cycle in essence, because you have all the pieces that you need to move, which is our end goal, to move those sensitive processes involving agents and AI from Web 2 centralized infrastructure to Web 3 decentralized infrastructure, but still keeping the guarantees around privacy.
Yeah. From a builder's perspective, you guys are really on the bleeding edge of some incredible technologies, whether it's the ZK side, whether it's the Web3 side. I'm curious what challenges you've experienced or interfaced along the way that maybe have impacted how you're thinking about the future for the network itself.
Yeah, we've had a lot of challenges initially because we were building something completely new that no one had done before. We couldn't lean on off-the-shelf components beyond what Cosmos provides. But that's just the blockchain element of it. But the other clusters that I was describing, we had to start from scratch. So that's why we spent the first 2 years heads down building that material. And then after that, we started working with the wider community, reaching out to developers. And that's also where we started refining our services. So the ones that I mentioned before are very core components. We call them blind modules. But on top of that, we're building to make it more accessible to developers. We're building SDKs. So you have, for example, an SDK for AI, and it has private RAGs, it has private inference, it has agents, so that without knowing all those nuances and details around cryptography, you're able to use that off the shelf as a developer, and that was designed with developers, because we didn't know what that should look like unless they told us. So we've been working with what we call founding entrepreneurs, which are kind of developers we work very close with, to define those SDKs. Another SDK is data analytics, whereby you can develop applications to capture information from your users and then run computations on those, and you can build things like data to earn applications or things like that, and so on and so forth. There's a number of them. But the idea is that we had to take this additional step from those blind modules, which are still very low level, and come up to this SDK layer to be able to be useful for developers and to be able to interface with them as they would with a normal SDK. So that was a very important component, I think, of the equation.
Yeah, no, that makes a lot of sense. Are there any other applications or use cases that gets you personally really excited, maybe independently from the AI stuff, things like IoT or supply chains that you're looking at with these other founding entrepreneurs and you're getting excited around?
Yeah, I'm very excited around encrypted order books. I think that's a very interesting application. In general, DeFi is very exciting. For example, I was talking the other day to a developer about lending. Most applications are around collateralized lending, because uncollateralized lending requires credit scoring, and it's very hard to get credit scoring in Web3 unless all your assets are in Web3, which might be the case for some people on X, but usually it's not the case for other people. So you need to reach out to external sources, for example, TransUnion, Equifax, whether you pay your phone bills and things like that. And that's very hard because that's private information, sensitive information again. But now with this platform, you can do that, and you can work with that information towards building a credit score that can be then used by under-collateralized lending solutions. So that's, I think, a very interesting use case as well. Data analytics, I think, is super cool because it's about bringing, there's a lot of applications building right now on Nillion, which are about building your, for example, health information, like all the things you capture with your wearables, into this platform that then others can use in exchange for some payment to you. So for the first time, you are in control of your data, and you decide how to monetize it and who can see what. Usually they don't see the data itself, but just the results from computations. And you can see things like, for example, there's correlation. There's people doing studies like that may reveal things like, there's correlations between the level of noise from people in Germany and compared to the people in the States, and the relationship between that and the hours of REM sleep that they have and the quality of their sleep. So cross-matching, cross-correlating all these things provides new insights in a privacy-preserving way for companies. And it's also interesting for you because you have your place where you can put all that information and have a single repository for all of that. And you don't need to trust any centralized service provider with that sensitive information.
No, it's incredible. I can just think of, I've got my Deepen smart ring that I'm wearing, and so that's collecting data. I map with Silencio, so I can absolutely appreciate all the opportunities and intersections of this data, but it has to be done in a privacy-preserving way because, to your point, customers and users are a little hesitant around letting that go out to the world, and so having a solution to that is really exciting. Are those the types of kind of founding entrepreneurs that you're working with? Are they primarily in the Deepen space with respect to things like gathering health data, gathering noise pollution, so on and so forth?
That's an important section of them, definitely. We have some others in the gaming area, but definitely within Deepen, that would be like the major chunk, the major tranche of them, yeah.
Yeah,
and it's
amazing.
really exciting because, as you say, that information is very appealing, is very useful, but if it falls in the wrong hands, because you don't have the privacy guarantees built in place, then those companies are definitely going to take advantage of that information. They could sell that information to insurance companies and say, oh, this person is not exercising enough, or things like that. They could even discover like some conditions, medical conditions that you have and you don't know about. So it can very easily turn against you if you don't control it. So that's why it's very important to flip things around and put you in control of that through proper access control mechanisms and this decentralized infrastructure.
Yeah, if it goes off the rails, it sounds like it can become Orwellian quite quickly, which would be a major problem for the world. No, I certainly can empathize with that concern. I know we've talked a lot about AI specifically. It's a hot ticket item right now with things like AI agents. Are there other applications within kind of the AI space that you're seeing synergies around, that you're excited about being able to leverage the network that you're building for those various use cases? Is that something you can share?
Well, yeah, sure. Beyond agents, I think private RAGs are very interesting. So retrieval augmented generation, whereby you have this database of sensitive documents and you use it to enrich the prompts that you send over to the AI agent or LLM. And it's obviously very important to keep that database ideally in a decentralized infrastructure, which is what happens in Nillion, and also being able to query it in a privacy preserving way. So that's a very important use case. It's very interesting for companies as well, because they typically have that knowledge base, but they don't want to share it to the company running the AI. You have also things like anonymization of prompts and things like on the training side, that's a little bit more futuristic, but on the training side, you have data aggregation with quality assurance and normalization. So this is about, it falls a little bit in the bucket of the data analytics that I was mentioning before. The idea is that the training data that you use for a network, you dump it into this decentralized infrastructure, you run all the normalization and quality assurance checks in a privacy preserving way so that you don't have to share that data. And then you run training on it, again, using something like federated learning with secure weight aggregation using multiparty computation. We have already done some POCs on that, how to train a network with all the information that we have using federated learning, but then aggregating the weights in a privacy preserving way, because those weights still reveal information, still leak some amount of information, but you can use MPC for that. And also private synthetic data generation. That's another interesting, I think, topic, whereby you use data, private data, to actually build a generator of private data that you use, that is anonymized, but you use for training purposes. And then I think it's going to be in 2025 that people are going to start talking about robots. And one of the key elements in robotics that current LLMs don't have is the episodic memory, is the ability to process episodes in your life. So you have a robot sitting in your home, for example, and it's watching you, and it's going to be able to process information in terms of episodes. Oh, my master went to the toilet. Oh, my master had an argument with her partner or his partner. Oh, my master did this or that. So obviously all that information is super sensitive. And again, this type of technology that Nillion is bringing into the equation helps in protecting your privacy when you will have in your home these useful, but nevertheless potentially dangerous robots.
I definitely, we don't want to have sort of the Terminator style future where these things, when I saw the Optimus demo that Tesla recently did, I thought, man, I definitely want to have one of these in my home. But you're right, it could go off the rails if done incorrectly, where you don't have these provisions in place. And so it's incredible to hear. I'm curious, you said in 2025, are there specific robotic applications that you're looking at? Are these things like an Alexa device that you might have in your home or something a little bit more sophisticated?
Yeah, we're looking at it right now in the research space. So we are toying with the idea of launching maybe some research on this front, because we think people are going to start talking about robots, and people are going to realize that they need this episodic memory, and that's essentially a spying tool, can become a spying tool in the wrong hands. So we plan on having collaborations with some research partners to work on this, but it's early stage still because we don't have the technology yet. LLMs haven't solved for this problem yet, for this episodic memory yet. So we're a little bit way. This is a futuristic approach, but it's starting now. You need to start working on this now, so that whenever this becomes a reality and all of us have a robot at home, we can provide this technology to help alleviate the security and the privacy problem.
Yeah, no, I really appreciate that. It is one of the things. I saw this demo a handful of months ago. I know a lot of people have smart robots for vacuums at their house. These things have been around for a while, but I saw one for a lawnmower, and I thought, man, if that thing went off the rails, a lawnmower gone rogue could be very problematic for the health and safety of people in the family or in the neighborhood and whatnot. There's just all these frightening potential problems that could manifest as a result of things going off the rails.
Yeah, definitely. If you think about it, it's gonna be, our houses are gonna be populated. They are already by Alexas and IoT devices that have a lot of sensors, and the information they process are gonna be ubiquitous, and there's gonna be plenty of them, and they're gonna get smarter at extracting value from that information. So this is the recipe for something really scary, and you have to have those controls built in on time before it's too late.
Yeah, it's great that you guys are on the forefront of ensuring that reality does not manifest itself in problematic and scary, frightening ways. For just folks that are really understanding kind of where Nillion fits into maybe a broader landscape, we were talking a bit before that you're a Deepen project, but you're also your own creation, if you will. How do you compartmentalize or categorize what you're building as just a project? Are you a Deepen? Are you a L1 for privacy and security? Just how do you explain it to people when you're giving your elevator speech?
That's tricky. We usually don't try to get that deep, because then it triggers more questions like, what are we? We are Deepen in certain sense because we provide all this infrastructure, and also, so you can look at it from the standpoint that nodes collaborating in those clusters are sharing their resources, be it storage or compute, for what is a Deepen network in essence, and privacy is an important component of that. But you can also think in terms of this infrastructure intersecting almost every vertical in Web3. So DeSci, DeFi, DAI. It really touches on all those things, because privacy is something that is ubiquitous. It sits across the whole spectrum. So maybe as an infrastructure project, we are Deepen, but the applications you can build on top of us don't necessarily have to be around that. You can also do other stuff like the decentralized AI or other things as well.
Yeah, no, I think that's a great way to explain it for those that are trying to put it into a mental model that makes sense to them. You guys are building so many different incredibly novel things within the project. What's next for the team? What's on the roadmap? Things for people to get excited about, or maybe they are unaware of as of now?
Yeah, I think one important element is community. So community-wise, we're really excited. I think we're really lucky, to be honest, with the community that we have. For example, we launched this verifier program. We recruited more than 500,000 in a few months. Now we have also node operators. We have operators for the nil blind computers for the different clusters. We have the founding entrepreneurs that I mentioned before, both coming from Web3 as well as from Web2, which is interesting, because before Web2 people wanted to do things, but they would immediately stumble upon the problem of privacy. And now they can actually do Web3 stuff, but still keep their look and they still develop their ideas around Web2 applications with privacy. Also, L1 and L2 partners like Near, Arbitrum, Aptos, Say, IONet, Ritual. The wider community is really exciting in Discord and hackathons and whatnot. So I think one important next step is about growing that community. That's why I personally are shifting from the core tech, from cryptography, and are also now more in contact with the builders, with the developers, and working in the solutions engineering part. So now is the time for to drop the pencil and the maths and actually meet with people and see what they want to build and how that maps into the platform and technology we've built. And regarding the technology, the great next step that we have is launching the Mainnet and also launching the token. And that's going to happen very soon. So we're really excited on that front.
That's very exciting for all of those that have been participating that are going to become participating. Do you have general rough timelines around when Mainnet will be launched with the token?
It's imminent, but I cannot share, unfortunately, any particular date.
Understood. We'll definitely be on the lookout for that release and that announcement when it comes out. Speaking of, where are the best places for people to go and learn more, stay in contact, get updated with what you're doing at Nillion?
Yeah, so I think a good place to start with is nillion.com, our website. So on the top right corner, you have all the social media handles you have. If you're interested to get news about what we do, the best one is X probably. If you're interested in participating a little bit more in the community, then Telegram. If you're technical, so you're a developer, probably Discord is the best one. We're always open for via email or whatever if you want to contact us that way. And if you want to look into things that can be built with our network and also the documentation, you can go to docs.nillion.com and see, you can link from there to the different demos and see use cases and applications that can be built on our technology.
That's incredible. We'll definitely link all of that below for folks to go find, get involved, learn more, because what you're building is really important and it is wide. So it's great to be able to showcase some of those different applications for people to maybe get the creative juices flowing, if you will, for what can be built within their own networks. Miguel, we've talked about so many different things. I really appreciate you taking all this time. Is there anything else we didn't get a chance to cover that you wanted to throw in before we get a chance to wrap it up?
No, I just wanted to encourage people to try out the documentations and the SDKs. We're seeing people build really exciting things. I really think that this is like changing gears in a car. It's like opening up a new design space that wasn't possible before. So there's a lot of room for creativity and innovation. So I encourage all of you who have business ideas or who are developers and want to maybe be in contact with people with business ideas to join our network and our community. I think you're going to be surprised by all the exciting things and projects that are being built on top of our infrastructure.
All right, that sounds fair enough. Miguel, I really appreciate you coming on. Like I said, taking all the time to explain what you're building. It is very exciting. It's really important for the world as we move forward. And so it's incredible that you guys are doing the work that you're doing. But with that being said, everybody, we'll wrap it up here. We'll have all of those links down below so you can go learn more, get involved, become a part of the community. This is certainly a project to not miss, especially as they are transitioning into Mainnet. So there'll be some exciting announcements, I'm sure, coming out very soon. But Miguel, I want to thank you again for coming on. As I said, we'll wrap it up here and we will see everyone on the next one. Thank you so much. Take care.
Thank you, Tyler. Thank you, people.
Cheers.